This is building Salesforce1 applications with Angular and Node. Just a quick note before we begin. I'm sure you guys have seen this already, but just a note about Safe Harbor. Just make buying decisions only on products that are commercially available at this time from Salesforce. All right, so again, good morning. My name is Matt Darnall. I'm a mobile developer at Salesforce. And I work at up north in Portland, Oregon at this lovely building. And I'm a part of a small team up there building mobile applications for the employees at Salesforce. Now our team spent the last 7 months or so building on the Salesforce1 platform. And I wanted to just get up and talk to you guys a little bit about how we're doing that. So I want to talk a little bit about the stack. But first, for those of you who aren't necessarily familiar with Portlandia, it's not only home to an awesome Salesforce office, but it's also known as Soccer City, USA. This is the view of from the Timbers Army at a Portland Timbers game. And the Timbers Army is kind of the local group of fans who are so passionate about soccer that make those games such a lively experience. As you can see, flags are a big part of Timbers games. And some of us on the team are pretty passionate about soccer as well, so one day we decided to hang a flag in our office. That flag's a Cascadia flag. And for the longest time, I thought it was just kind of a cool logo, a cool flag. But as I looked into Cascadia a little bit more, it's actually a perfect metaphor for the stack I'm going to talk about today. So for those of you who aren't necessarily familiar with Cascadia, I want to just kind of briefly describe what it is. First, it's a bioregion that kind of makes up the Pacific Northwest of the United States and Canada. But second, it's a cultural movement that aims to define kind of the music, the culture, the food, even the sports of that region. And lastly, and I think most interesting, is that it's an independence movement. The movement, I think, is best summed up by saying, Cascadia seeks to help further local autonomy, empower individuals and communities to better represent their needs. And I found that this really embodies why we as a team like this stack for building Salesforce apps. We think that this stack is a set of technologies that helps teams and individuals really empower themselves to build great apps. So when I say, how does it meet our needs, let me kind of explain that a little bit. First, this stack gives us the most freedom to develop apps with technology that we feel best suits us. We had developers on the team who didn't necessarily have Force.com development experience, but instead more traditional web development experience. And I think that this stack really enables us to realize that potential as developers. The next thing is that we wanted to really develop without friction. This stack really enabled us to rapidly prototype apps, as well as debug everything locally as developers on our own workstations. So I think, let's face it, building cross-device mobile apps is already hard enough, and there's nothing more frustrating than making that process any harder than it really has to be. The next thing is agile delivery. We really wanted to have a truly agile development experience and release our apps early and often. And we wanted to really leverage the power that you have with a web as a platform by doing that. And I think with this stack, you're able to really reduce the surface area of what's deployed to your organization down to merely configuration. So with all that said, here's really the stack that I'm talking about. We're using Canvas to display our apps inside of Salesforce1. We're using Heroku to run, scale, and build our NodeJS applications. And we're using Salesforce as our data provider. So with those motivations in mind, it's time to get our hands dirty and kind of build something to get a high-level sense of what it takes to build something with this stack. So here's an app that our team built kind of when we were first exploring this stack. It's called the org chart. It's an app that you can use to browse kind of the hierarchy of an organization within Salesforce. Originally, I wanted to dive into its code base as an example, but in 30 minutes, there's not really time. So instead, what we're going to do, we'll build a simple addition to this app. We'll list out the accounts in our org and then use that list of accounts to pick which account we'll browse with the org chart. So let's start with walking through the steps of getting our new app running inside Salesforce 1. The first thing that we need to do is set up a connected app. And there's just a few things that I want to highlight here. The first is that we'll set this connected app as a Canvas app. We'll set its access method as signed request. And we want to make the app URL something localhost that we can develop against. So we'll do localhost/signed request. And then the last thing that we need to do is make sure that app is available as a location in the mobile nav. Next, we just need to enable this connected app for users. So we're going to make sure that users are pre-authorized by the admin, and then we can set what profiles that we want to enable for this app. So for my purposes, I'm just going to set that up as the system admin role. And then the final step is mobile navigation. This will give us the left nav item to access our application. So once we have that, we're ready to kind of check in and see where we're at. Let's bring up Salesforce 1 in the browser, and we'll use one.app in the browser to load this up. And I'm just going to use a Node module called happy.js to run the Node server and add server-side routes to respond to these. So I'm going to jump to the command line, and we'll use npm to install happy. So it's npm install happy, and we'll save that as a dependency to our project. We'll let npm do its thing. Great, so we have that installed. And what I can do with happy is add routes to my server to respond to certain requests that are coming in. So I'm going to start with adding just a simple route. You give it a HTTP method, and this method is going to be post for our signed request. Then we'll set it up to be the path that we've configured on the connected app. So that's /signed request at our local server. And then happy just has a pretty straightforward interface for defining our handlers. It's just a function that takes a request from the client and then can reply back to that client. So for now, I'm just going to simply reply with hello Dreamforce, right? Let's just make sure that we're up and running correctly. And I'm going to jump back over to the browser. We're in one.app here. I just want to make sure that in the left nav, our newly connected app is there, and it's org Zizzle. So let's open that. Great, so we see hello Dreamforce. So we know we're in a good spot. All right, what's next? Now we need to actually handle the sign request to actually do anything interesting. The sign request, once decoded, will give us information about the user, including their OAuth credentials, that we can then use to fetch data with. It also actually provides you some other interesting information, like the context in which this application is running. In our context, we're running in the left nav, but other interesting things like the screen real estate you have available to you, and some other interesting information and metadata. Luckily, decoding the sign request is really straightforward and easy, and we're going to just take advantage of npm in a Node module called Salesforce signed request to do that heavy lifting for us. So I'm going to jump to the command line again, and we're going to use npm to install Salesforce signed request and save that as a dependency to our project. Once we get that, let's change our route handler here to not just reply. First, I need to import that module that we just installed, and that module exports a decode function that I'm just going to save as a local variable here. So instead of replying with hello world, let's decode the sign request. So I'm going to set up Canvas context just as a local variable. That will be what we actually decode into. And then again, I mentioned you need the client secret, and this is where that comes into play. I've stored this in just a configuration object, but this could be an environment variable or anything like that. Now it's time to actually call decode. So we'll use that decode function, and we'll set its result to the Canvas context. So sign request comes as a post, and inside the body you have it keyed off of signed underscore request. So we're going to pass that into the decode, and then we pass our client secret. Now we want to make sure that decoding didn't involve any errors, so we're just going to check that the canvas context, if it is an instance of an error object, will reply with the fact that that happened. So we'll reply with error. And for now, let's just reply with the raw decoded message that we've gotten and check our results here. So if we jump back over to one.app, we should now load our app and get the fully decoded canvas context. Great, so now we're actually getting OAuth credentials. So now we can actually get some data, and this is where I think it starts to get exciting. So we have access to the user's OAuth token, and there's a couple options in terms of how we go about getting this data, so let's walk through a few of them. The first one I'm calling here is just direct to API. So this option uses JavaScript running on the client to query the Salesforce APIs directly. Now, typically you can't do cross-domain requests like this when your JavaScript is coming from a domain that's different than the API that you're querying. But Canvas has JavaScript SDKs that handle this case for you. Let's look at another option though. The next option I'm calling just is API through the Node server. This approach actually exposes a more custom API through our Node server that our client can interact with. And the Node server can query the Salesforce API as it sees fit and return the data that it knows that the client needs. So let's go to the command line here and implement that API to retrieve the accounts from my developer org and return them as JSON. And I'm going to start by leveraging, again, NPM and Node and the great ecosystem of modules out there, and use something called JSForce, which is a JS library for querying the Salesforce APIs. And this module is actually really cool because you can not only use it in Node, but you can use it in the browser and even on the command line to kind of do some debugging and prototyping. So I'm going to jump to the console. We'll use npm to install JSForce and save that as a dependency again. Let npm do its thing. And then we're ready to actually use that. So I'm going to create a new route here on the server. Now the method's going to be get this time. Our client's going to be making a request against /accounts. That'll be our custom API that we'll expose to the client. And then again, we get the same handler interface with a request and a reply object. So I'm going to delegate here to the a custom accounts API object and ask for all of the accounts. And that's going to return a promise. So when that promise is fulfilled successfully, we'll get back the accounts data that we're interested in. Then we're going to reply with that accounts, and we'll also handle the error case here to make sure if that promise is resolved as an error, we'll reply with that as well. So pretty straightforward in terms of the handler code. The more interesting code is this accounts API wrapper object that we'll code up here. So I'm just going to import and require that into this file, and then we can jump to that and actually implement it. All right, so what do we need to do here? Well, JSForce starts with a connection. So I'm going to require JSForce and then actually save off its connection object. And then I've got just a helper API function that I'm going to use to actually do the connection that's using the OAuth credentials from our client. So I'm going to require that object as well. Next, we need to implement that all function. So we'll export the all function. And this is where the heavy lifting actually occurs. We're going to query the API, the Salesforce API, for the accounts objects. So we need to create a new connection from JSForce. So we'll do that, new connection object. And then everything is async here, so it returns a series of promises. So we need to open that API connection. And then we're going to actually run the query if that opening is successful. So the connection at that point can actually be used to run a query. So we'll say connection.sObject. We need to tell JSForce what sObject we're interested in. And in our case, it's the account sObject. And then we're going to call find. And we're interested in all of the accounts. I'm not going to limit that query at all, but I am going to limit what I get back. So we just need the ID property and the name property, so I'll specify that. And then by calling then, we'll kick off that query and the series of promises that come back in an async fashion. So we should be able to test this now. Let's jump to the command line, and we'll just use curl to make sure that we're in a good spot. We'll curl against our local API, and what that's going to be doing is actually hitting our Salesforce API and getting back the list of accounts in our developer org. So we'll go to localhost/accounts, and then we'll just pretty print that. Sweet. So now we get back the list of IDs and names of the various accounts in our developer org. So that's the option in terms of getting data from Salesforce that I'm calling API through Node. But you can actually, this is a pretty simple example, right? You can actually do a lot of other interesting things with this approach. One advantage our team's kind of exploring is, what if we could cache this data globally and make the responses of our APIs quicker for users in other parts of the globe? Well, with Heroku's offering in the EU, you can actually do that. You could cache this service locally in the EU on Heroku and make that happen. So next up, let's look at another approach for getting data. It's a relatively new approach, but actually one that I'm pretty excited about. And that one's Heroku Connect. So Heroku Connect is interesting because it takes care of syncing all of the S objects that we're interested in between Salesforce and a Postgres database on Heroku. Why I think this is cool is that you can then leverage all the power of Postgres, and Postgres has an amazing community of plugins and interesting ways to manipulate your data, but also still have that flexibility of implementing a custom API for your clients in Node. So it's pretty easy to set up and to configure. We just need to tell Connect what S objects we're interested in. So here's my dashboard for Heroku Connect. And what I've done here is just mapped the account object that we're interested in. And then I've set it as a read-only access mode, but this can actually be bi-directional syncing, so we can do read and write syncing. And then I've set this up to pull every 60 minutes, but that can be almost instantaneous if we want to. So with that configured, let's modify our last API example to instead use Heroku Connect and the Postgres database running inside of Heroku. And again, I'm going to leverage the power of NPM and Node modules to do this for me and pull in a library called Connects.js. And it's just a library for doing SQL queries against many different types of databases in Node. So I'm going to use npm to install connects, and we'll save that as a dependency. Cool. And then this is going to be actually really similar to the last one. I'll create a wrapper object to access that database called accounts.db. We'll just require that into our route handler. And then we're going to create a new route on the server. So again, very similar to the last route. The method's going to be a get call. But we need to differentiate the path, so I'm going to just use /v2/accounts, kind of a second version of the API, if you will. And then a handler, again, the same API, request and reply. So we'll delegate to that accounts.db object, and it's going to have the same really interface that we had before. We're going to ask for all the accounts. That'll return a promise. We'll hook into that promise. When that successfully is resolved, we'll have the accounts that we need. And we'll just reply with that to the client. We'll handle the error case too, because we're good citizens, right? And let's jump to the accounts.db object. So we need to actually implement the query against the database here. So I've got a helper file called db that just helps us connect to that database with the right credentials. And then we need to implement that all function. So we'll export that as a function. And its implementation is pretty similar, but we basically connect to the database, so we'll call db connect. And then at that point, we actually can run SQL queries against the database. So we'll select out the SF ID. That's equivalent of the ID inside the S object that's being synced as a column. And then we'll pull out the name. We'll specify what table we're going to go against, so it's prefixed with the word Salesforce. And then we'll call then to kick off the query and return a promise. So if we jump back to curl, we'll test the exact same thing and make sure that, that we're getting data. But again, the interesting thing here is that we're getting data from a database on Heroku. All right, so we have the data that we need. It's time to build up a UI to display it. So what we want to do at this point is build up a UI to kind of list those accounts that we're getting from our API. And then we're going to link into the org chart application with the right account ID so that we can browse around on that. So I'm going to use Bower to install our front-end dependencies, and I'm going to bring in Angular and Ionic. If you guys haven't seen Ionic yet, it's a pretty cool library or framework for building mobile UIs. It's built on top of Angular, so by pulling in Ionic, we also get Angular. So let's do that now. We'll jump to the command line and we'll use Bower to install Ionic. And at that point, we have those dependencies available to our project. So first I need to start at that signed request handler, and instead of returning just the raw decoded message, we're going to return some HTML. So I've set up a home view and we'll reply with that view. And then we need to pass in the canvas context so that we have that credentials. If we go check out the HTML for that, the first thing to notice is that I've got Ionic CSS and JavaScript embedded in the page. And then I've created just a simple controller for Angular. And when this guy comes into existence, the only thing we really need to do is go fetch that data from our client API. So I'm going to kick off a new HTTP call, and again, this is just matching our server route. It's a GET call against, we'll use the second version of the API /v2/accounts. And like most things in JavaScript, these are all async, so we'll hook into it as a promise. When that successfully comes back, we're just going to set a property on the scope called accounts, and that's just going to be the array of accounts that we get back from our API. And we'll handle the error as well. For now, we can just console log that that we kind of ran into an error at that point. So if we jump back over, the last thing that we really need to do is we have that data now on the scope. We need to iterate across array. So I'm going to use Ionic's content pane to give us a nice scrollable content of all the list of accounts. And then we're going to use its list view widget. So I'm going to pull in Ion list, and for each account I'm going to set it up so that the Ion item repeats over that array of accounts. So I'm going to give it an ng repeat for each account in the accounts array, and then we're going to set up that link to our org chart app. So I've got org chart running locally in this case, so I'll set up localhost, and then we need to make sure that we pass in the right account ID that we've queried. And that's pretty much it. The only last thing that we need to do is set up what we'll display for each row. So I'm just going to output the account name to display in the UI. So if we jump back to the browser and reload this, what we're going to see is we're doing the query against our Node API, we're getting the accounts, and then we're building up a UI of those accounts. And for each account, I've set up kind of some dummy data in the org chart. So we can kind of see what that looks like. So here's our list of accounts in the Ionic list view, and I'm going to select the Walt Disney Corporation. And there we go. We get org chart now browsing the context within that organization. And we can jump around, check out Daisy Duck, Mickey Mouse, and we'll check out Mickey Mouse's direct reports. And so this is the org chart browsing the data that we have inside the developer org. So I just want to kind of recap what we saw. I know this is pretty condensed into a 30-minute talk, but really what we saw is the ability to embed any web application inside of Salesforce 1. I think Node and Angular make for great technologies for building those apps, but really it can be any application inside of Salesforce 1 using the stack. And then we saw a couple different options for getting data to the application that we need from the Salesforce APIs. And again, there's plenty of options to do whatever meets your needs. But I think most importantly, we talked a little bit about how this is actually a really viable stack and a viable option for individuals or teams that have similar needs to our team. If you want to empower yourself for those reasons that I said before, then this is a great option for you. So that's it, guys. I put together a link bundle on Bitly. It's DF14 Cascadia. This has a bunch of links for all the various technologies that we talked about today to find out a little bit more. And then if you guys have any questions, we'll take some questions afterwards, but also Twitter is a great way to get a hold of me. That's my handle. And then if you guys want to stick around, I got some great Cascadia flag stickers if you guys want a little bit of swag. So again, thank you for spending your morning talking about Angular and Node apps inside Salesforce 1. Thanks, guys.